And so we're going to do algebraic functions. So we're going to talk into a polynomial. So polynomial is a variable of expression x in the following form, and so we say a sub n times x squared, so times a sub n minus 1, x to the n minus 1. So technically, remember that x to the 0 power, anything to 0 power would be 1. And so technically here we could say x to 0 power. So that's why the notation is the way it is. It's just whatever power a would be the coefficient for that. Okay. So this comes up. Knowing that this is x to 0 is useful to know. It comes up, but I wouldn't worry about it too much right now. So here, these are all real numbers. So this meaning real numbers. So it means that a naught is an element. So this means an element of, you may not know this, element, let me write this so you guys could read it. Element of, and this of course means the reals. So that means a naught is some real number. And a to the n is not 0 because if it's a to the n, you could just say, I have a polynomial of a lower degree. The degree of the polynomial is stated by the highest power, so in this case n. The number of terms determines the name or type of the polynomial. One term is a monomial, 2 terms is a binomial, 3 terms is a trinomial, and after that we just really don't name them. So let's get into some of the names so you can understand. So here, this is a monomial because it only has one term. And what degree is this? Well, this is degree 0. Degree 0. Why? Because the highest power here is x to the 0. Does that make sense? So we kind of say it has degree 0. Most of the time, what you're going to do is just call this a constant. That's usually, you don't usually say it's degree 0. You usually say it's a constant. Here, we have a binomial. And here, the highest power here is 1. So we say that this is a degree 1. Here we have a trinomial. It has 3 terms. So this would be a trinomial. This would be a binomial. This is a monomial. The monomials, the term only applies to how many terms it has. Once again, this is a trinomial. Okay. So what's the highest degree? So the degree here, the highest degree here is, so this is a degree 2. The highest degree here is degree 3. What is the degree of E and F? Go ahead and put that in chat. What is the degree of E and F? So what are these degrees? 9 and 5 is correct. So notice sometimes they don't always give you what the highest one is first. So this is just asking, are you paying attention? Yeah, so here we have 9 and 5. Okay. All right, so when adding and subtracting polynomials, we combine like terms, so term with the same variable raised to the same power. Okay, so that has to be very, very clear. It has to be the same variable or variables sometimes. So the degree is the highest exponent. Yes, the degree is always the highest exponent. And it's always in these cases going to be an integer. So here we have degree of 5, since that's our highest exponent here. Let me kind of get rid of that so you can see it. So here we have degree 9, here we have degree 5. It's not the first term or the degree of the first term, it's the degree of the highest exponent. So yes. All right. So when we add or subtract, we always have to combine like terms. So you can combine like 3xy to the 4th. plus 5xy to the fourth equals to 8xy to the fourth. So you can combine variables, but they have to be the same set of variables put together. Okay. So here, if I want to simplify each of the expressions, what I usually do in order to do this is I look at, I usually work from the bottom up, which sometimes is confusing, so I'll do the top down. So what is the top thing here? Our top here is x to the fifth. Do we have any other x's to the fifth? No, so we're just going to write that down, x to the fifth. All right, now we're going to do x to the fourth. Here's an x to the fourth, here's an x to the fourth. So I'll have 3x to the fourth plus that's going to be 4x to the fourth. So then we'll have x squared. Do we have any x squared terms? No, no x squared terms. Or I guess the next one will be x cubed. So the next one is x cubed, so I have 3 plus that, so that'll be 4 x to the third. X squared, we just already stated there is none. So go ahead and just skip it. The next one is x to the first power. There's only one. I'll put it in a box just to be different. So it'll be 5x. And then our last term are our constants, and we only have one constant left here. Okay. So you just do it term by term. When you're doing this right here, when you're simplifying this expression, please do the following. Before you do a single solitary step, distribute your negative. So make this positive, and this will be minus x to the fourth. You know what? Let's just clear the parentheses altogether. I distribute the negative, so it goes here, it'll go here, it'll go here, and it'll go here. So this becomes plus x to the fourth minus 3x cubed minus x plus 7. Now, do you have to do it this way? No, but if you do it this way, you will not have, it makes it a lot harder to accidentally forget the negative sign, right? Because sometimes you'll see 3x and an x and you'll write that is 4x instead of getting to minus here. So I like to clear out my parentheses when I'm doing these things. It just makes life easier. So I can just add up like we did before. Here our highest one is x to the fourth. So I have 2x to the fourth. You know, minus, if we're bringing the negative sign here, this is minus x to the fourth, right? Be very careful. So 2x to the fourth minus x to the fourth just gives me x to the fourth. So when I do this personally, I cross off the terms I've used. That way I've seen it. X cubed, there's only one x cubed, so it'll be minus 3x cubed. I'll go ahead and cross that off. That's just for my own bookkeeping. You don't have to. 3x minus an x will be plus 2x. So I've done that. I forgot the x squared. I totally skipped the x squared, so let me go back. And that's exactly why I do my bookkeeping the way I do my bookkeeping. Make sure I don't forget terms. 3x plus 2x, then I'll cross these off, and plus 7. And so one thing when you do big things like this, you're going to have to develop, yes, you are correct, my friend. When you do a big set of numbers by hand, you're going to have to do some way of doing bookkeeping, right? Some way of saying, I've dealt with this term, okay? Like you saw me actively make a mistake. And I'm not being cheeky. I'm like, oh, I planned it that way. When the teacher says I planned it that way, 90% of the time they lie. They just make mistakes like humans do, right? Unless they say it with like, sometimes they're being facetious with you and just joking with you. It's like, oh, it's this, right? Then they kind of planned it that way. But it's a good thing in all your math to develop techniques to do bookkeeping for large problems, especially in engineering, because you're going to get equations later in college that are just disgusting. There's no two ways about it. So develop some sort of bookkeeping method. All right, so let's go here. So in multiplying on two binomials, we use FOIL first, outside, inside, last. For larger polynomials, we just plain old distribute. And so what does that mean? Here I did an example for you. So here if I did this, I would distribute the 3x to, I guess I'm distributing all of this into the 3x, and then all of this into the 2, and then combining. We sometimes call this expanding. Some people call it just along with distribution. There's a bunch of formulas here that you're kind of supposed to have in your pocket. And so as you do calculus exams and other math exams, almost all the professors will expect that you kind of know these. So kind of memorize these. So if you have a difference, so a plus b and a minus b, you get a difference of squares. Or if you have a difference of squares, this is what we call this, a difference of squares. It equals a plus b, a minus b. Okay. Here, if I square something, this is just binomial expansion. We'll get into that in a lot of detail later. I have negative, here we have this, and then here, a plus cube. So here it'll be plus 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 with 3's here. A minus, and then here it'd be a minus plus minus. And this all comes from, you'll learn that this comes from the Pascal's triangle, or Pascal's triangle is one way of visualizing this. So notice here you have the 1, 2, 1 structure. Here you have the 1, 3, 3, 1 structure. And if you had a quartic, it'd be 4, 6, 4, 1 structure. We'll get into this later, but this is just a little preview. So here, if we wanted to find each of the products, how do we do this? Well, here we're just going to, so here we're just going to square this. So here I'm going to actually try to use the formulas to get you used to the formula. So here would be this squared, so 3x squared. Please notice that you cannot put this in here and put this in here and call it good. This is not okay. You have to, that this is 3x plus 4 times 3x plus 4. At this point, you can FOIL. That's perfectly fine. Or you can use the formula. Let me actually FOIL, which will show you the formula comes out to be true. So first would be 3x times 3x would be 9x squared. So outside, outside, don't mind my dyslexia, so I'm going to make sure I'm doing it right. So it'd be 3x times 4, so that'd be 12x. Inside would also be 12x. And then last will be 4 times 4, so it'll be 16. When I simplify this, plus 24x plus 16. And notice that 24x is also 2 times 12x, or a times b. So here this would be our a, this is our b. So I have a squared, so 3x squared, times 2 times ab, which would be 12x, or 24x in this case, plus 16. All right. We're going to do C now, and then I'm going to actually show you just using this procedure. So here, a squared squared would be a to the 4th plus 2 a squared times b plus b squared. So here I'm just using this formula right here, where a in this case isn't a, but a squared. So here would be a squared 2 a squared b times b squared. So here's I'm just using the formula. All right. Let's go ahead and do this one. So here we have 2x plus this. And so the only way to do this is distribute 2x times x squared minus 5x plus 4 plus 3 times x squared minus 5x plus 4. All right, so here we have to deal with this. So I'm going to do another step beyond this. So I'm going to just go ahead and put this in. So this will be 4x cubed minus 6. Oops, that's a 5, sorry. Minus 10x plus 8x. And then here, if I did the 3, it would be plus 3x squared minus 15x. Well, that should be squared. Minus 15x plus magnifier off. And then if I simplify that out, so here I'm doing, this turned into this. And so if I simplify that out, it's 4x cubed minus, oh, there's no, hold on. Is this a 4? There's no 2 here. There's no 2 here. This is 2x cubed minus 7x squared. 15 minus 8 will give me minus 7x. Then the 12. We're done. All right, so let me show you. Let's just use the formulas real quick to produce these answers. So here, we're going to use the formula to figure out what this is. So here, we're going to have a cubed. And so 2x cubed would be 8x cubed plus 3 times a squared. So 2x, so it'll be a squared would be 4x times b, so it'd be y, plus 3 times 2x times b squared, so it'd be y squared, plus b squared, which would just be y to the third. And if I simplify that, I get 8x3 plus 2 plus 6, sorry, xy squared. Okay. Does everyone see how I produce this using this formula up here? So this is my a cubed, or this is my a and this is my b. This would be my 3a squared b. This would be my 3ab squared, and this is my b squared. Move this down. You can do the exact same thing here to produce the same answers. And I'll just give you this one. I'll give you this one to check next time. I don't want to spend too much time on this. Oops. X squared plus 108 x minus 27. And so notice here, if I take this and cube it, I'll get this. If I take this and cube it, I'll get this. If I take this, let me kind of break down what one of them is. So here, this will be minus 3 times 16x squared times 3. And so if you add all of this together, you get 9 times 16, get you this mess right here. Okay. So notice here, I'm declaring A to be 4x and B equal to 3. Now, if I had B equal to -3, I would use this formula, not this formula. So it depends on where you grab it. And one last thing I want to show you is if here, if I declare this to be A and this to be B, what is this? Well, this is just the difference of squares, right? So here I have, oops, hi, A, B, B. So if x plus y is A and 2 is B, I'll have A plus B, A minus B. So I can write this as x plus y squared minus 2 squared. And so you can write this in this form. Keep it simple. If I wanted to expand that out, that'd be x squared plus 2x xy plus y squared minus 4. Okay. Any questions on this page? It's a lot of just kind of doing algebra. We find in calculus, it's, do you have a problem with the present box method? I'm not positive I know what problem. I don't know if I know that method. Or at least I don't know it by that name. It's just a method I'm used to. It's hard to do with cubes. Oh, I think isn't that where you put each one into a box, each of the binomials in the box or something, and do it that way. Yeah, I think that breaks down once you get into higher orders. So if I was taught it, I forgot it. If you do stuff using different methods, I have zero issue with it, right? Zero issue. But I don't know if I know that method that well. Sorry about that. All right. So let's talk about factoring some expressions. So we want to factor some stuff. We can factor each one of these. So here, I'm going to pull out everything in common. Everything in common in this is an x. So I can pull out an x here, and I get x equals 4x plus 3. Here, there's a lot of things in common. So everywhere has at least 2 x's, so I can pull out an x squared. I have a 2, at least everywhere, so I can pull out a 2. And then for y's, I have at least a y squared, so I can pull out a y. And then here, so divide by 2, I'll get 4. Divide by the x squared, I just get a single x. Divide by the y squared, I guess y squared. Plus here, I've actually pulled out everything. But please be sure, if I divide this by this, I don't get 0. I found a lot of times when students factor this out, they just throw it away. Please leave the 1 here. And then here I'd have a 3xy. Notice here, in both of these terms, I have so terms. So this would be the first term right here. This is the second term. Terms in an expression are there's either a minus sign or a plus sign separating them. So in my first term, I have x plus 1. My second term, I have a factor of x plus 1. So I can pull it out as a factor for the term. And then I'll have 2x plus 2 plus 3. Which here I can simplify this to x plus 1, 2x plus 5. Okay, so we can use these ideas to do more complicated. So here, let's go ahead and do this. So here we can use more complicated. We can use this method to factor by grouping. You can do it by dividing the final square and then solving for it in the box. Factoring is my favorite thing to do. Oh, good. I'm glad you have some fun with that. Yeah. Okay. So here we can factor. So when you factor by grouping, you usually group the first two and the second two together. This is almost how it's always done. So you can group these two together. So what do these two have in common? Well, these two have in common. Let me step back 1 second. Let me step back 1 second. Usually, how you recognize something is factorable by grouping, because when you get a calculus, you're going to just see this and say, okay, deal with this, right? It's not going to say factor. It's not going to say any of this, right? It's just going to say, what's this? And you're going to have to go, oh, one of the things that I probably most beneficial for me to teach you is how to recognize a problem when you see this. Notice here we have repeated coefficients. We have a 1 and a 1 and then a 3 and a 3. And so it has the same pattern. Here, what do I have for repeated coefficients? I have a 1 and a -2, and then I have a -3 and a +6. And so this is twice the negation, right? And here it's twice the negation. So that's kind of how you recognize it. Get rid of that since we're actually doing it. And once you recognize that you have a pattern, that this pattern matches this pattern matches this pattern, you go ahead and group the first two together and the second two together and see what you get. Does that make sense? Can we go back to see? There we go. And so here we have x squared plus, here I can pull out an x squared. I can pull out more than an x. I can pull out an x squared. So I have x plus 1. Here, I can pull out a 3. So I have 3 times x plus 1. Now, once I have this, I can move it together. And here I have x plus 3, x minus, or x plus 1. We can do the same thing here. Here I can pull out an x squared, and I have x minus 2. Here I can pull out a -3, and then I'll have an x minus 2. Once we do that, I have x squared minus 3. And then x minus 2. And so here I'm grouping them up. So here I have this factor everywhere. So I'm going to pull it out of the expression. So what's left out is this over here. Here I have x squared and minus x, pull that out, and I get this. All right. The other thing for factoring, let's go ahead and do this, is to do is to look at this. And so here sometimes method reverse FOIL or by finding common factors. So how do we do this? What we do is we look at the factors of this right here. So the factors of this, so notice that this is positive. So since this is positive, we're probably going to want the positive factors here. So I have 1 and 12. Technically, you have -1 and -12, but that's never going to get you to where you want to be. So if this is positive, this is positive, it's almost always positive. So I'm going to skip the rest of the negative ones. I'll have 2 and 6. I'll have 3 and 4. And that's the rest for the positive. And then I'm going to figure out, so I'm going to find the factors of this. And then I'm going to figure out which of these add up, which of these add to this. So I'm going to factor this, figure out which of these add up to that. Should be an x next to 7. You was dead right. There should be an x next to that 7. Thank you. I do type all these notes, and so there will be small errors throughout them from time to time. So here, the 4 and the 3 add up to 7. So what do? We have x plus 3, x plus 4. And a quick way to check this is you just go ahead and expand it again. You just expand this again and get back to here. Okay. For this one's a little bit more complicated. Here, we don't know that this comes out cleanly, but let's suspect that it does. And if I suspect that it does, I'll have a 3x and a 2x. Or I'll have a 6x and an x. And then here, it gets kind of more complicated as you take factors of this. So be minus 5 and 1, and hold on. 5 and minus 1. So you factor the 5, and then you kind of plug and play what fits here. It's actually really cumbersome, right? You plug and play here, so is this 3 minus 5 plus 1? Does that give you what you want? The answer is no. You take 3 plus 5 and minus the 1, does that give you what you want? The answer is yes, and so that's the real answer. But let me show you how to do this in a computer. Show you how to do this in a computer real quick. All right, so here, when you're working with this, you're going to use two things for your expressions. There's going to be the vector expression, so factor, and then you can type in something. Oops, get rid of this. So our expression here was 6. Hold on. 6x squared plus 7 minus 5. And so that gives us what we want. So you type in factor, you'll get something like that. And here, the opposite of this is expand. So if I want to expand a polynomial, you'll just type it in like this, and this will expand it out for you. Okay, so it's good to know how to have the computer do each one of these for you. So you can just hit, just expand it, it'll do what you want. Okay. So going back to this, so you just plug and play and test until you get this, and then once you try all the combinations of this with this, you find out you get a working one. Once you find a working one, as we did here, so 3x plus 5 and 2x minus 1, notice here that I get 6x squared. This ends up to be negative 5. No, I was trying to get out the 7x in the middle. So 5 plus this gives me plus 10x minus 3x gives me positive 7x. So that's the way it works. Usually if you get something funny like this, most of the time you're just going to type it in a computer. Okay. All right, we have 1 page to go and 10 minutes left of class, so we're doing great. All right, let's do the last page. All right. So let's go through this. So here, these are just the reverse of everything we see, right? So special factoring formulas. This is zero difference between this one, the expanding formulas. These are not the same. The only difference is which way you're going, right? So here, if I want to factor this, I'll go through this one. For this one, we're going to go ahead and skip H. I will tell you straight off the back. This is just something the book does for fun. Yeah, it's good to know. Don't worry about it. Just don't worry about it. So let's go into some factoring real quick. So if we're going to factor these, so what do we have here? We have a square minus a square, right? So let me zoom in. So here I have a square minus a square. So here I have a squared minus 16 squared. So what's the square here? Well, a, let me be very clear here. A is 3x. 3x squared is this. B is minus or positive 4, right? In this case, 4. So here, if I have this squared is that minus this squared is this, I know what this is. It's just right here. So it'd be 3x plus 4, 3x minus 4. Okay. And factoring these squares in would be really nice. So here, let's look at this one. Let's go ahead and do this one, D next. So we're going to have A here is x, y minus, x minus y. And B here will be 2. Same idea, same expression. So we have x minus y plus 2, and then we'll have x minus y minus 2. And so here, these a's do not necessarily have to be a single term. They can actually be multiple things put together. Just makes your life easier. Here, if I was going to factor this, the first thing I would do is just pull out common terms. So here I can pull out an x and a y squared. If I do that, I get x to the fourth minus y to the fourth. Here, and then here I can factor this. This is the difference of squares where a is x squared and b is y squared, so it'll be x squared plus y squared and x squared minus y squared. Does this make sense, everyone? Let's go ahead and stop on this one for 5 seconds. Does this make sense, what I did here? I looked at this and like, okay, let's factor first. I have common terms. I'm pulling that out. Then I get x to the fourth minus y to the fourth. Well, that looks like a difference of squares where the square would be x squared. Or here, if I have difference of even things, I can just cut it by 2 and write it this form. Does that make sense to you guys? Hopefully. No one's saying it doesn't. Yeah, okay. Here, if we have the cubes, here the cubes are a little bit harder for you to recognize, but this factoring tends to be useful. So here, for my cube, I'm going to say a is equal to 2x. My b is equal to 1. I'm going to be using this formula here. So I have 2x minus 1, so a minus b times b squared, which in this case will be 4x squared plus 2x plus 1. So I'm just using this formula up here. So a squared would be this. AB would be 2x plus 1. Here I have the positive version. Here I'm going to let x a equal to x squared. So x squared cubed is x to the 6th. And then we're going to let b here a cube. So this would be again 2. Uh-oh. Uh-oh. Mm-hmm. I need to check something real quick. There might be a typo on these. No, no, these are right. No, it's right. I'm just being paranoid, which is good. It's good to be paranoid when you're doing math. Double check things. Here, if I have this, so what do I get here? Well, here I'll have x squared minus 2. Oops. X squared plus 2. Sorry, I'm using this formula now. That'll be x to the fourth minus 2x squared plus 4. Just following the formula here, plugging in these values. Here, notice this is a perfect square. So this is a completed square, so I should be able to recognize this is x plus 3 squared. And the reason you can recognize this is that this, I take this is a square, and what's here is half of this square. When you complete the square a lot, you'll actually see this one more. So I'll just fall out. And then here, we're going to put the same thing here. We're going to pull out 2x squared, and then I have x squared minus 4. Same concept here after we factor. X squared, see x plus 2, x minus 2. You know what? Let's do this one real quick. Oops, my little factor didn't go. This should be to the minus 1/2 here. It just didn't put it up as a caret. Here, if you have something that looks super, if you have awful fractions, go ahead and just take the lowest one. And even if it's negative, just divide it out. So I'm going to take x to the minus 1/2 out. And in fact, I can pull out a 3 as well, so I might as well do that. So this just becomes, so if I pull out a half, this goes up by a half, and so this just becomes x squared. This goes up by a half, so this just becomes x, so minus 3x. And this goes up by a half, so this just becomes 0, so just 6. So this is a very useful technique to have in your pocket. If you see something super strange, just pull it out. And then here you can continue to factor this mess. Just factor this normally, and you should get x minus 2x. Oops, here, I forgot to pull out the 3. Please be careful. And that's it. And that's the end of the notes for the day. Okay. I'll leave this up for a second.